So today we will see the mechanical properties of the material. So in previous lecture we completed the physical properties of the material and chemical properties of the material. Today we are going to see the thermal properties of the material. So the thermal properties of the materials are very important. So the engineering materials are important in everyday life because of their versatile structural properties. Thermal properties of engineering materials are diverse, and so their uses in different applications are there. Thermal properties are those property of material which is related to its conductivity of the heat. So thermal properties are mainly related with the heat or conductivity of the heat. Means the thermal properties of the any materials are dependent on the conductivity of the heat. Okay. In the other word, these properties are which are displayed by material when heat is passed through it. Okay. Means when we will get this property, thermal property, whenever there is a transformation of the heat. Okay. So whenever heat is passed through the material, we can consider it as a display of the thermal properties. Okay. Also, thermal properties of material refer to the characteristics behavior of material under thermal load. Means whenever heat is applied, such load is called as a thermal load, and at that loading condition, we will get the thermal properties of the material. Other than this property, they do play an important role because of their physical property. Okay, so there are different thermal properties are available. So first important thermal property is the thermal conductivity. That is nothing but a transmission of heat from one body to another body is called as a thermal conductivity. Then thermal expansion is the second property which is related with, which is again a thermal property of the material. Next one is a specific heat. It is also a thermal property of material. Melting point of the material and thermal diffusivity of the material. So as discussed earlier, all these are related with the heat. That's why these properties are called as a thermal property. Now first property is the thermal conductivity. Thermal conductivity is nothing but a transmission of the heat from one body to another body through a media, like a material. Okay, so we will see one example or the animation of the term thermal conductivity.
Now, what is thermal conductivity? Well, the most easy definition of thermal conductivity is how heat can readily be transferred from a hot object to a cold object by a metal. For example, during cooking, metallic pot absorbs heat from the flames and transfer it to the food or vegetables. This property of the metallic pot is known as the thermal conductivity. Secondly, when you keep something in the micro oven, again the metallic plate absorbs heat and transfer it to the food. So this heat transferring property is known as the thermal conductivity. Thus we learn that thermal conductivity means how heat can readily be transferred. Now let me teach you that many students misunderstood the concept of thermal conductivity. You should note it down this example. Consider a hot object and a cold object. Now, if I connect these two objects using a metallic rod, heat will transfer through this metallic rod to the cold object. So this transferring of heat or heat conduction through the metallic rod from the hot object to the cold object is called thermal conductivity. Let me repeat it. This transferring of heat or heat conduction through the metallic rod from the hot object to the cold object is called thermal conductivity. Remember that different objects have different thermal conductivity. For instance, consider the same hot and cold objects. This time, instead of metallic rod, I insert plastic rod between them. We will observe that comparatively less heat will transfer from the hot object towards the cold object. Thus, we therefore say that metals like this rod have high thermal conductivity, while non-metals like this plastic have low thermal conductivity. If you wonder about this difference in thermal conductivity, then the answer is very simple. Within metals, there is a sea of delocalized electrons. Delocalized electron means free electrons that can move from one corner to other corner of the metal. So metals therefore have high thermal conductivity, while non-metals do not have a sea of delocalized electrons, but they do pass heat due to phonons, which are waves in the lattice. One of the best applications of thermal conductivity is designing cooking objects like this kettle. Its body is made up of metal like steel or iron, etc. Its handle is made up of plastic. Because metal conducts more heat and water or tea will absorb more heat, thus it will reduce the cooking period. Secondly, its handle is made up of plastic because plastic materials conduct less heat. And when we touch the handle, less heat will transfer to our hand. Different objects have different thermal conductivity. For example, the thermal conductivity of copper is 401 watt per meter Kelvin. The thermal conductivity of styrofoam is 0.03 watt per meter Kelvin. The thermal conductivity of vacuum is 0 watt per meter Kelvin. It means no thermal conductivity in the vacuum. To summarize my lecture, we learned that thermal conductivity measures how heat can readily be transferred from a hot object to a cold object. For example, during cooking, the metallic pot conduct heat. Secondly, we learned that metallic objects conduct more heat than non-metallic objects. For example, the body of kettle is made up of metal and handle is made up of plastic. This was all about thermal conductivity.
Okay, so from hot body to cold body, whenever there is a transformation of the heat, that term is called as a thermal conductivity. Next important property is a melting point. So melting point is the temperature at which material goes from solid to liquid state at 1 atmospheric pressure. So melting point state as a transition point between solid and liquid phases. Melting point is the temperature at which pure metal or compound changes its state from solid to liquid. So this is the very simple term, melting point of any material. Whenever we are providing the heat to any material, its initial stage is a solid state. Whenever we are increasing the temperature at one point or peak point, what happens? That material loses its solidity and start converting into the liquid form. So whenever there is a conversion of solid state into the liquid state for that particular material, that temperature point is called as a melting point. So the melting temperature depends on the interatomic and intermolecular bonds nature, means how the atomic arrangement is present for the material. Depending on that, the melting point is different for different material. So therefore, the higher melting temperature is shows by those material processing stronger bonds. Means the materials which are having a stronger covalent bonds or ionic bonds, the materials which are having the high melting point, and the material which are having a low or weaker bonds, it has a low melting point. So they can be easily melted from providing the heat. So covalent, ionic, metallic and molecular are the types of solids, and they decreases order of bonding strength and melting point. So this is the term melting point of material. Next is the electrical properties of the engineering material. So electrical properties are their ability to conduct electric current. Various electrical properties are resistivity, electrical conductivity, temperature coefficient of resistance, dielectric strength, and thermoelectricity. Okay, so electrical properties are nothing but the properties of the material which are related with the electric current. Okay, means whenever there is a flow of current through the material, such a property of the material is called as a electrical property. So the important electrical properties are electrical resistivity, electrical conductivity, temperature coefficient of resistance, dielectric strength, and thermoelectricity. So some of the important properties or electrical properties of engineering materials are as below. So each and every engineering material can show the following electrical property, which are metal. Okay. So electrical resistivity is the first electrical property of engineering material. So what is meant by electrical resistivity? So it is the property of material which resists the flow of electric current through the material. Means whenever there is a resistance offered by the material for the flow of electric current, such a property of the material is called as a electrical resistivity. So it is the give and take of conductivity. So the resistivity value are reported in micro ohm centimeter units. As mentioned above, resistivity value are simple give and take the conductivity. Means whenever there is a resistance offered by the material for flow of electric current, that property of the material is called as the electrical resistivity. Second important property is the electrical conductivity. It is the property of the material with which allows the flow of electron through the material. So the term electrical conductivity is nothing but whenever the flow of current occurs, a flow of electric current occurs through the material, such a property of the material is called as a electrical conductivity. So it is the parameter which indicates that how easily electric current can flow through the material. So the conductivity of material is give and take of resistivity. So electrical conductivity measures of how well material accommodates movement of electric charge. Okay. So the movement of electric charge is also called as a electrical conductivity. So electrical conductivity is very useful property since values are affected by such things. Therefore, electrical conductivity information can be used for measuring the purity of the water, checking for proper heat treatment of metals, and inspecting for heat damage in some materials. Okay, means if electrical current is flowing through the material, then we can easily identify whether the heat treatment is proper in the material, whether that heat damage is occurred in the material. Dielectric strength, it is also electrical property of the material. So it is the property of material which indicates ability of the material to withstand high voltage. Means the material which is sustained at high voltage value, that property of the material is called as a dielectric strength. Okay, so it is usually specified for insulating material to represent their operating voltage. Which material having high dielectric strength can withstand at high voltages. Okay, means if voltage value is very large, then which type of material is sustain that voltage is called as a dielectric strength of that material. Next is the temperature coefficient of resistance. Temperature coefficient of resistance of material indicate change in resistance of material with the change in temperature. Okay, means whenever there is change in temperature, there is a change in the resistance of the material. Next one is a thermoelectricity. So it is the link formed by joining the two metal is heated, a small voltage of millivolt is produced. So such a effect is called as a thermoelectricity or thermoelectric effect. So thermoelectricity is the term where if we form or if we link form by joining two metal is heated, a small voltage of millivolt is produced. So after thermal property, now we will see the mechanical property of the materials. So mechanical properties of material help us to measure how metal behave under the loading condition. Means whenever we are applying the load on a particular material, what will be the behavior of that material that can be identified or predicted by the mechanical properties. In order to achieve optimal system performance, mechanical properties include density, hardness, and elasticity. Okay, so these are the most important mechanical properties of the material: density, hardness, and elasticity. So the mechanical properties of the material reflect relation between its response to the deformation from an applied load or force. So whenever we apply the load, there will be the certain deformation. So that relation related with the property that can be achieved by using the mechanical properties. Okay, so the properties of the material that find out its behavior under applied load is called as a mechanical property. The properties of the material that find out its behavior under applied load are called as a mechanical properties. So the important mechanical properties, we will see what are the important different mechanical properties are there. So first mechanical property is the strength, or it is also called as the stress of the material. So strength, it is the mechanical property that enable a metal to resist deformation. So the resistance offered by the material for deformation under the loading condition is called as the strength of the material. Resistance offered by the material for deformation or to resist the deformation under the applied loading condition is called as the strength of the material. The another definition of the strength of the material is its capacity to withstand destruction under the action of the external load. Means whenever we apply the load, it should be sustain that loading condition. That term is also called as a strength of the material. So the stronger the material, the greater the load it can withstand. Means if the strength of the material is high, the material can withstand at high load. If strength of the material is low, then it can sustain low loads. Okay, so the stronger the material, the greater will be the application of the load withstand capacity of the material. So the formula for the strength is the load per unit cross sectional area of the material. So it is generated by S or letter sigma. Force per unit area is the formula, and the unit of the strength is Newton per mm square. So this is the SI unit of the strength. So this is the first strength of the material. Second mechanical property is the elasticity. So it is the ability of the material, or elasticity is the ability of an object or material to resume its normal shape after being stretched or compressed. Means whenever we apply the load, the material can deform, and whenever we remove the load, the material can regain its original shape and size. So here you can observe one example of the elastic material, rubber. So whenever there is a tensile load or load is applied, it will get elongated, and whenever load is released, it will regain its original position or original shape and size. Such a property of the material is called as a elasticity. So when a material has a load applied on it, the load causes the material to deform, and whenever load is removed, it regains its original position. So the elasticity of the material is its power of coming back to its original position after deformation when the stress or load is released. So the examples are heat-treated springs, rubber are the good example of elastic material. This is again important mechanical property of the material. Next important property or mechanical property of the material is the plasticity. So the plasticity of the material is its ability to undergo some permanent deformation without rupture or without brittle. So the plasticity of the material is nothing but whenever material undergo a permanent deformation without failure. Such property of the material is called as a plasticity. Means whenever we apply the load on the material, it will get deformed, and whenever we remove the load, it does not goes to its original shape and size. Such a property of the material is called as a plasticity. So plastic deformation will take place only after the elastic range has been extended or exceeded. So piece of evidence of plastic action in structural material is called as a yield or plastic flow and creep. So the materials such as clay, lead, etc. are plastic at room temperature and steel plastic when at bright red heat. Means whenever heat treatment is performed, it will get permanent deform. Such property of the material is called as a plasticity. Next property, important mechanical property of the material is the hardness. The resistance offered by the material for penetration is called as a hardness. So the hardness is the ability of material to resist scratching, abrasion, cutting, penetration. So hardness is nothing but resistance offered by the material for scratching, abrasion, cutting or penetration. So hardness indicates the degree of hardness of the material that can be imparted particularly steel by processing of hardening. So it determines the depth and distribution of hardness is introduced by the quenching process. So this is the one example of hardness. Diamond is the material which is the hardest material having high hardness value. So hardness is measured in the number, it is the unitless quantity. Next important property is the toughness. So it is the ability of the material which enables it into the withstand the shock or impact load. So toughness is the opposition condition of the brittleness. The toughness is maybe a considering the combination of strength and plasticity. Means the total curve under stress strain diagram is also called as a toughness. So the energy or shock wave sustainable capacity of the material is also called as a toughness. Okay. So manganese steel, wrought iron, mild steel, etc. are the example of the tough material. So this is again a very important property of the material. Next property is the brittleness. So the brittleness, it is also a mechanical property of the material which enables it to withstand permanent deformation. Means cast iron, glass are the example of the brittle material. So there will be a less amount of deformation in the material. So whenever we apply the load, it directly deform and permanent deformation is obtained in the material. Such material is called as a brittle material. So brittle material will break rather than bend under shock or impact loading condition. So generally the brittle metals have high compressive strength but low tensile strength. So this is the important property of the material. Next important property, mechanical property is the stiffness. So it is the mechanical property. Stiffness is the resistance of material to elastic deformation or deflection. So the resistance of the material for deflection or stretching or elastic deformation is called as a stiffness. So in stiffness, a material which suffers light deformation under load has a high degree of stiffness. The stiffness of the structure is important in many engineering applications. So the modulus of elasticity is often one of the primary properties when selecting the material. So stiffness is denoted by K and the unit of the stiffness is Newton per mm. Next property of the material is the ductility. Ductility is the property of the material which enables it to be drawn into the thin wire. So that is the ability of the material to drawn into a wire form. That material property is called as a ductility. So mild steel, copper, Aluminum are the good example of the ductile material. Next, malleability. The ability or malleability is the property of a material which permits it into a hammered or rolled into the sheet of other sizes and shape. Okay, so malleability is the property of the material by which whenever we can apply the force, that material can convert into the sheet roll form. So the example of malleability material are aluminum, copper, tin, lead are the good example of the malleable material. So you can observe one example here. The bottles which are made up of a aluminum material are showing the malleability property. Next property, mechanical property is the cohesion. So it is the mechanical property. The cohesion is the property of solid body by virtue of which they resist from being broken into fragment. Okay, so that is the important property of the material. Next property is the impact strength of the material. Whenever the impact strength is the ability of the metal or material to resist sudden applied load. Okay, so whenever we apply the sudden load on a particular material, and the material or metal sustain that sudden applied load, the property of the material is called as a impact strength of the material. Next important mechanical properties, fatigue or fatigue life. So fatigue is the long effect of repetitive straining action which causes the strain or break of the material. Means whenever there is a application of the alternate tensile and compressive load for a particular period of time, the material will get failed. Such a failure is called as a fatigue. And if the material sustain that load, alternate cyclic repetitive load, that property of the material is called as the fatigue strength or fatigue life of the material. Last important property is the creep. So the creep is the slow and progressive deformation of material with time at constant force. The simplest type of creep deformation is a viscous flow. Some metals are generally exhibits creep at high temperature, whereas plastic, rubber, and similar amorphous materials are very temperature sensitive to keep. The force for specific rate of strain at constant temperature is called as a creep strength. Okay, so this is also important mechanical property of the material creep. So in today's lecture, what we learn different thermal properties like thermal conductivity, melting point, specific heat of the material, then different mechanical properties of the material like creep, cohesive strength, then hardness, toughness, ductility, strength of the material, fatigue strength, impact strength. Okay, so these are the various important mechanical properties of the material. So in next lecture, we'll see the another topics of our subject.